Today I'm going to present Retroactive Auditing. My name is Yuan. This is joint work with Nicola and Franz from my team. So imagine you are a system administrator and you're reading this piece of news from Slashdot. You see huge banners that you use like exploits. And you might be wondering like, okay, I also have a server running Apache. And it could be also compromised to want to know the answer like part of my servers. Are they also compromised? Well, this turns out to be a very hard problem. Like first, the administrator doesn't know like exactly is there any exploit because the server could be continue to run normally, and if there are any backstores in stores, you don't even know if there are any. It just looks like exactly the same. So we need some auditing tools to help to find out if there's any exploits in the past. Existing work include the rule-based tools like Tripwire, which basically watches for suspicious file system changes, if there are any changes to password or something like that. They do not work for general exploits. For example, if there's any attacker hijack your traffic and modify your HTTP responses, there's nothing they can do. Another work is introvert, which basically uses the virtual machine techniques to replace past execution with handwritten predicates. So it involves some human effort because you have to write predicates for every manipulated here. So there are two major disadvantages from this work, basically generality and human effort. So our idea, we are proposing here, is to provide a general framework which does not require any human effort here. So this, the big idea here is what the system would have been like if the patch was originally a patch. So basically, we assume there's a logger that records everything, every past execution and replay it. And so first the system is rolled back to previous state and fit in original input. And now we start two copies. One is the patch code, one is original code. I'd like to see the system state would be different, and that's then we'll get some conclusion here. So we have some assumptions. First, we assume the patch itself is correct. It actually fixes the vulnerability. We also assume the replay itself is faithful. It actually the vulnerability would manifest itself the replay. And we also assume the tool itself is it's not tampered with by the attacker during auditing. So if the tool see there's no difference, the output is no, and we could conclude here okay, there's no vulnerability now. Go back to sleep. And if it says yes, then it could be attacks, it could be false alarms. So the first challenge we are trying to solve is false alarm here. There are also other challenges because now we are just reading every input. So basically it means you want to audit 2-week execution. It takes another 2 weeks to do the auditing stuff. And also we haven't done much how to do how to secure the replay itself. During the replay logs have to be secured, and during auditing, the process, the auditing tool itself cannot be subverted. And there are also further steps. Now if you know that your servers are compromised, what can you do? Can you do recovery, or what can you do next? In this talk, I'll focus on the first item, false alarm, how to reduce false alarm. So we are using Apache 2.2 as a case study. So we basically summarize 36 vulnerabilities in the 6-year time span. It's a very complex program because